Hey guys, welcome to Conceptual Geometry, lesson 3.4. We're going to continue talking about properties of a rectangle. Just a quick review of our notes from the day before. We talked about the properties of a rectangle and specifically the two that distinguish it from a parallelogram. It has four right angles and the diagonals are equal. So let's get right to, here we are, where we left off. Okay, in rectangle FIJG, if FH, so FH is this segment right here. Let me trace that. So if FH is 7y plus 10, and segment IH, that's that piece, is 4y plus 46, find IG. Well, again, it's going to be a little bit of work because that's not one of the pieces they gave us. But remember, in a rectangle, the diagonals are equal and they bisect each other. So all four of these segments from the vertex to the center are congruent. So the first thing I'm going to do is set up a simple equation to solve for y. 7y plus 10 equals 4y plus 46. Let's subtract 4y from both sides, and at the same time I'll subtract 10 to move it over to the right side of that equation. 7y minus 4y is 3y. 46 minus 10 is 36. Let's divide both sides by 3. So y is 12. The question wants me to find IG. IG is the entire diagonal. So what I need to do first is I need to find this piece, and I'm just going to double it. I just think that's the easiest thing to do. So first, let's find IH by taking 4 times 12 plus 46. Okay, and I'll just plug that right into my calculator. 4 times 12 is 48. 48 plus 46 is 94. So then IG is going to be 94 times 2, and it's going to be 188. All right, so again, the equation's not really that bad, just setting those two equal and solving for y. But finding that missing piece, which was the whole diagonal, involved a little bit more work. All right, question 5. I love this question. In rectangle FIJG, if the measure of angle 1 is 23 degrees, so I'm going to throw that in the figure right now. That's 23 degrees. Find the measure of angle 2. Well, the reason I love this question is there's so many different ways to do it. But probably the easiest is to pick out this triangle here. Well, it's a rectangle. So what you know is that this angle right here is 90 degrees. So in my green triangle, if I want to find angle 2, all I have to do is take 180 minus 90 minus 23. All right, and that's going to be 67 degrees. Many other ways to find it. That's just the quickest. All right, now we get into some pretty challenging questions. It says if the sides of a rectangle are 6 and 8, determine the length of the diagonal. Again, this is geometry. If you don't see a figure, you're going to draw one. So we get to practice drawing rectangles. It only talks about a diagonal, so I'm only going to draw one. The lengths of the sides are 6 and 8. So basically, what I'm talking about here is a special kind of triangle. We just talked about it in the figure before. This is a right triangle. I'm looking for a missing side. I know these two are 6 and 8. Remember the good old Pythagorean theorem. 6 squared plus 8 squared equals x squared. Now, I'm just going to put these right into the calculator. 6 squared plus 8 squared. Throw that into the calculator. That gives you 100 equals x squared. Square root it. X is going to be 10. Now, you might remember me telling you earlier in the year that we have certain combinations that are always right triangles. And one such combination is a 6, 8, 10 triple. And that's one we're going to see all the time. So if you knew that, you'd recognize this as a 6, 8, 10 triple. And you wouldn't have to go through all this work here. You could just write x equals 10 and then just make a note that it's a 6, 8, 10 triple. Okay, last one. A little bit more challenging. So this says in the accompanying diagram of rectangle ABCD, diagonal AC is drawn, DE, so DE is 12, okay, it's labeled, AE is 5, and EC is 16. DE is perpendicular to AC. Okay, there's the right angle, it's drawn. Find the area. Well, we haven't talked about area yet, but it's pretty easy. Area of a rectangle. There's a formula, length times width. We're going to talk about it as base times height. But if you notice the figure, I don't know the base and I don't know the height. But I've got a bunch of right triangles. I know that's going to be a right angle. I know that's a right angle. So let's work on this triangle here to find the missing side. We just got done talking about the Pythagorean theorem. So in this triangle, I know one side is 5, the other one is 12. I want to find x. Notice x is the hypotenuse. It's across from the right angle. So to set that up, I would do 5 squared plus 12 squared equals x squared. All right, or you can call it the height, h, if you want. Throw that into the calculator. That's going to give you 169 equals x squared. Square root it. X is 13. All right, so my height is going to be 13. I just want to point out this is another very, very common triple. This is a 5, 12, 13 triple. It's one of the three I told you to remember. 3, 4, 5, 6, 8, 10, and 5, 12, 13. Okay, moving on. So I need to find this side here. Well, there's a couple ways we can go about doing this. I could use this big triangle, which looks like it might be more work, so I have to add these two numbers together. But notice I could also use this. Since the opposite sides are the same, let's call this, I'll call it y, or you can call it b for base. This side here is the same as this side here. So I think it might be easier, because the numbers are smaller, if I focus my attention on this triangle. Also right triangle. I know this side is 16. I know that side's 12. And I'm looking for my hypotenuse. I'll call that y. So in this triangle, I'm going to have 12 squared plus 16 squared equals y squared. I'm going to throw all that into the calculator. All right, I put that into the calculator. I get 400 equals y squared. I square root it, and I get 20. That's not a triple, so don't worry about that. I had to use a calculator. That's going to be 20. So now, finally, I want to find the area of this rectangle. Well, it's base times height. My height is 13. My base is 20. So this area is going to be 13 times 20, which is going to be 260. So kind of a cool problem. It involved a rectangle. We had to recall some information about area of a rectangle and our Pythagorean theorem to find the base and the height. All right, that concludes lesson 3.4. Thanks for watching, guys. As usual, if you have any questions, don't hesitate to reach out. We'll see you in class soon.